Okay, so if we had square root of 3 times square root of 5 minus square root of 8, you just go ahead and distribute it. Same way you would if you had variables. Okay, so that's square root of 3 times square root of 5 minus square root of 3 times square root of 8. Okay. Now, once you have it like that, you want to remember one thing. So if you had square root of a times b equals square root of a times square root of b, it works both ways. So if you multiply two roots, you can combine them under the same root bracket. So this would just become square root of 3 times 5 minus square root of 3 times 8. Same rule, just different direction. Okay, so we have square root of 15 minus square root of 24. Okay. Now with 15, you can't factor out a perfect square, so that's pretty much going to stay the way it is. But 24, you can maneuver that one a little bit. The square root of 24, we can just make that square root of 4 times 6. Okay, so if we go ahead and just separate those, that would be square root of 4 times square root of 6. Square root of 4, we know that's just 2. That's just 2 square root of 6. So this simplified answer will be square root of 15 minus 2 square root of 6. So you always want to be on the lookout for those perfect squares. All right. Yes? Sure.
So if you wanted to, could you, before you combine them under the same bracket, couldn't you just split up the 8?
Yeah, you could have done it that way. There's actually, you'll always find more than one way to do it.
Okay.
Yep, but if you want to make 8 2 square root of 2 and then distribute the square root of 3, you could have. Okay, any other questions on this one? All right. Leave that up for a few more seconds. So let's say if we wanted to multiply and simplify. Square root of 3x, that shouldn't be there, minus square root of 2y times square root of 3x plus square root of 2y. Okay, so with this one, I'm just going to rewrite it. The same way as if you had x minus y, x plus y, the first thing you do is just FOIL it out. Okay, so we multiply our first terms, which is square root of 3x times square root of 3x. Then you have your outer, which is plus square root of 3x times square root of 2y. Then you have your inner, which is negative square root of 3x times square root of 2y. Then you have your last, which is negative square root of 2y times square root of 2y. Okay, so if you notice, the two middle terms are opposite, so they'll cancel each other out. So you have plus square root of 3x square root of 2y and minus square root of 3x square root of 2y. Those just disappear. Okay, these two, you can go ahead and combine those under one square root. So you have the square root of 3x times 3x minus the square root of 2y times 2y. Or you can just go ahead and rewrite that as the square root of 3x squared minus the square root of 2y squared. The reason I wrote it like that is because now it's set up to where your root and your exponent cancel out. Remember, this is just 3x squared to the 1/2 power, so those two would just cancel out. So you'd end up with 3x minus 2y. All right, any questions on this one? All right, leave that up for a few more seconds. Right. Okay, so what if we wanted to multiply and simplify? Negative 3 times the cube root of 10y to the third power, and that entire thing raised to the third power. Okay, so you have two products, and both of those are raised to an exponent. So we know we're going to use a times b to the nth power equals a to the nth power times b to the nth power. Okay, so that means we're just going to get this exponent and distribute it to both. Okay, so our negative 3 times the cube root of 10y to the third raised to the third power is just going to become negative 3 to the third power times the cube root of 10y to the third power to the third power. Okay. So we know negative 3 times negative 3 times negative 3 is negative 27. It becomes negative 27. And this one, we can see that our exponent and our index are the same. So those two cancel out. So that just leaves whatever's under here, just times 10y to the third power. Okay. So the only thing left that you can do is just multiply those two. So that's negative 270 times y to the third power. All right, so any questions on that one? Leave that up there for a few seconds. Okay, so we did adding and subtraction, we did multiplying. Now we're going to go into division. Leave that up for a few more seconds. Looks like everyone's done writing. Okay, so we simplify radical expressions, so this time with division. Okay. And most of those will fall under what we call rationalizing the denominator. Okay. That's just a fancy way of saying remove all radical signs from the denominator. From the denominator. Okay. Now to do that, you want to remember a few things. Okay. So if we had like square root of 2 times square root of 2, that would just be square root of 2 times 2, just square root of 4, which is 2. So basically, we just saw that square root of 2 times square root of 2 equals 2. Okay. We can also see that square root of 5 times square root of 5, that would be square root of 25 if you combine them, which is 5. So square root of 5 times square root of 5 is 5. So if you have an index of 2, if you multiply 2 itself twice, the brackets pretty much just kind of disappear. They cancel each other out. So that means if you had cube root of, let's say, 3y. Let's say cube root of 3y times the cube root of 3y times the cube root of 3y. So we have an index of 3 and we multiplied it 3 times. So if we combined all of those under 1, it would just be the cube root of 3y times 3y times 3y. Okay, so remember that would just become the cube root of 3y to the third power, where your index and your exponent cancel each other out. So that would just be 3y. So all this saying is if you multiply it the same number of times to match the index, it'll always cancel each other out. And we're going to use that to rationalize our denominators. Oop, anyone's still writing. Leave that up for a few more seconds. All right, so let's say, for example, if you want to rationalize the denominator, of, let's say, square root of 20 over 7. Okay, so the first thing we're going to do is rewrite that. And we're going to use the fact that a divided by b to the nth power equals a to the nth power over b to the nth power. Okay, so if we started off with our square root of 20 over 7, then really that's just 20 over 7 to the 1/2 power. Okay, which means we can distribute that exponent to be 20 to the 1/2 power over 7 to the 1/2 power, which is just square root of 20 over square root of 7. So all of that just showed us that square root of 20 over 7 is just square root of 20 over square root of 7. So the same way you can separate when two square roots are multiplied, you can also separate them when you divide. Okay, so we're going to rationalize the denominator here by remembering that square root of 7 times square root of 7 is equal to 7. Okay, so that means if we start off with our square root of 20 over 7, we can just multiply it by square root of 7 over square root of 7. Okay, so we know that square root of 20 is just square root of 4 times 5, which is square root of 4 times square root of 5, which becomes 2 square root of 5. Okay, so that gives us square root of 20 times square root of 7 over square root of 7 times square root of 7. We already know that's 7. Okay, so if we go ahead and simplify our square root of 20, like we did already over here, we have 2 square root of 5 times square root of 7 over 7. Okay. Now the same way you can separate, you can bring them together. So square root of 5 times square root of 7 is square root of 5 times 7, which is square root of 35. So this can become 2 square root of 35 over 7. All right. So any questions on that one? Yes.
Where do you get 1/2 from earlier in the question?
Oh, the square root. Remember that the square root of x equals x to the 1/2 power. So the square root of that entire fraction just means that entire fraction is raised to the 1/2 power. So you can always change it from square root to the 1/2 power. Okay. You didn't have to do it that way. It was just kind of a roundabout way to show you that you can just separate your square root. So if you went right to that and just separated it, you'd be just fine. All right, so we'll do one more example. I wrote more examples than I would need. I'll just scan those extra examples with the notes. Okay, one still writing. All right. Okay, so let's say, for example, if you want to rationalize the denominator of, let's say, square root of x over square root of x minus 3. Now this one's a little different from before because before you only had one term. And whenever you have one term, you just multiply it by however many root values you need, and you'll be okay. But when you have two terms, you always have to multiply it by its conjugate. And that's literally just a fancy name for changing the sign. Okay, so with two terms, multiply the denominator by the conjugate. Okay, so that means square root of x minus 3 has a conjugate of square root of x plus 3. Literally just changing the sign. Okay, so that means if we have our square root of x over square root of x minus 3, we're going to multiply it by square root of x plus 3 over square root of x plus 3. Okay, so for our numerator, we're just going to distribute, because all we have is square root of x times square root of x plus 3. But here we have square root of x minus 3 times square root of x plus 3. So we just distribute here. For our denominator, we'll apply the FOIL method. Because remember, whenever you have the same terms and the signs are different, the two middle terms just cancel out as soon as you apply FOIL. Okay, so you have square root of x times square root of x plus square root of x times 3 over, here you have square root of x times square root of x. For your first, your outer is 3 times square root of x. Your inner is negative 3 times square root of x. And your last is negative 9. Okay, so square root of x times square root of x, that's square root of x times x plus 3 square root of x over square root of x times x. Those two disappear, and you have your minus 9. So this gives you square root of x squared plus 3 square root of x over square root of x squared minus 9. Well, you know that exponent and your index automatically cancel each other out. So that will give us x plus 3 square root of x over x minus 9. All right. Any questions on that one? Yes.
So we can write the x minus 3, root x minus 3 and root x plus 3 direct to s square minus b square, right?
Yep. All right. Any other questions? All right. I have extra examples that will be scanned with the class notes. Oh, did everyone sign in?